Welcome, everybody. Good morning, good afternoon, good evening from wherever in the world you may join us today for this first webinar. I'll give the word in a second to Nicolas from ISA. Just a quick word in the beginning, because maybe not every participant can join today, but would like to watch the video at a future date. We will record this video and set it onto our YouTube channel in the future. Just that you are aware that you are going to be recorded if you ask any questions. And without further ado, I would give the floor to Nicolas.
Sure. Yeah, it's really excited to have with you this webinar. So I'm Nicolas Mjepe. I'm with the Philab at ISA. So we are based in Esri, nearby Rome, Italy. So Philab, I don't know if you're familiar with, we are part of the Earth Observation Program Directorate. So we do basically Earth observation. On top of that, we have the mandate to explore how disruptive and innovative technology could be integrated within the main stream activity of observations. We do basically AI, mostly self-supervised learning, foundation model, generative AI, computer vision, but also natural language processing. Not to forget like blockchain related topic, quantum, edge processing directly on board a satellite. As you may know, over the last year, we ran the so-called AI4EO challenge. The last one was called Orbital AI, so we closed it some months ago. And actually, the winners would have the possibility to fly the algorithm directly on board two spacecraft, the FISA-2 mission and the ISS. But today, this challenge is called the Map Your City Challenge. Next, Dennis. It has been co-organized by Nova Space. You see Dennis here in the call, a company based in Brussels. We have also Miners, an applied research company established in Switzerland, Italy. I'd like to thank as well Mattia and Alessandra joining this call. And just to let you know as well that the AI4EO challenge, and especially the platform, is also operated and maintained by different companies in Europe. For instance, we have Earthpulse in Spain. We have also Gematics and Playtech in Italy. And also we have the support from Planet, Synergize guys regarding the Jupyter Notebook. So I'd like to thank all of them for their contribution to this challenge and the platform in general. So today in the call, so yeah, we have Denis, we have Mattia, Alessandra, and I don't want to forget as well Nikolaus from ISA, research fellow at ISA Philab, that will present as well the data set and the baseline AI model. Without further ado, so let's start this webinar. I hope that you will enjoy it. There will be 3 parts in it. So first, Denis will give you a short introduction about this challenge, what this is about, why this challenge, and then we'll deep dive into the data sets and also we'll present you some baseline solution that was offered to you as part of the starter toolkits. And finally, we'll have hopefully a lively Q&A session with all of you guys. Yeah, so I hope that you got your coffee this morning and you are ready for this webinar. Over to you, Dennis.
Thank you very much, Nicolas. Maybe as a first quick word to all the participants today, we have a Q&A panel open. So if you click on the Q&A tab here in Zoom, you can at any point in the meeting add an open question that we can answer then later after the data introduction. Don't be shy. You can also, if you want to, anonymize your questions so you have their full transparency. But maybe a quick few words about the challenge before I give the floor to Nikolaus to talk more about the data itself. The Map Your City Challenge is looking at building age, or better, building age detection. What is building age? Building age pretty clearly refers to the time that has elapsed since a building was built. It's as that kind of acts as a time capsule. It reveals architectural trends, construction techniques, design philosophies. But why is it important that we look at building age? Because we can gain this way a lot of information about a structure's safety and integrity. This is very important if we look at city planning. This is very important if we want to calculate renovation and preservation needs to increase a city's overall safety and security. And current problems that we face is that building age monitoring is done manually mainly. Means that very hardworking people walk around the city and actually manually check buildings, check for preservation needs, check for maintenance needs. This is very time consuming. This is also very challenging because cities obviously or change swiftly a lot. So it can be very tricky to keep track of the building age of a city and the overall age. That is why automating building age detection is your task. You are supposed to merge perspectives, street level perspectives with the bird eyes view satellite data, and then help us in defining the automation of building age detection, hopefully for the future, so that in the future we can lower the tedious manual tasks and automate these tasks a little bit more. But I think most of you joined because you have questions about the data, about how to use the data, how to approach the question. And for this, I'm very happy that we have Nikolaus from ESA with us today. I will give the floor to him in a second, maybe just a few more words about the timeline and about some logistics of the challenge. So as you may already know, we will close the challenge on the 14th of July. Please make sure to submit your final solutions no later than 16 in the afternoon, so 4 p.m. in Central European time. Please make sure that your uploaded solutions include a test CSV file, including the added estimated construction time. We will award the winners later this year at the Urbis 24 workshop at ESA Esrin's premises in Frascati in Italy on 18th of September. And the 3 winning teams will actually receive a limited travel budget, so they could, if they want to, also attend this award ceremony in person. Of course, we try to be flexible here. If traveling is a bit too complicated for you, we can also arrange another setting. There, the winners are actually expected to present their solutions ideally. So be ready to pitch your solutions in, let's say, maximum 10 minutes and disclose the high-level algorithmic information that you have developed. And then maybe just a last point to organize the future of this challenge, to also communicate with you as a winning team. We will always talk directly to your appointed team leader. This will be our sole contact or reference of contact. So please make sure that we always are in reach of your respective team leader. If you have any questions, obviously just put it in the question answer tab and we can answer it at a later date. But without further ado, sorry, I almost forgot. There's something in for you. You can actually win a prize, 2,500 euros for the first prize, 1,500 euros for the second, and then 1,000 for the last one. So if you want a new graphics card or need some other new equipment, this may help. But without further ado, I would now give the floor to Nikolaus. Nikolaus, do you want to share your screen?
Yes. So I can share my screen now. Okay, so hello everyone. I will talk about the data introduction and use. So I'm Nicolas Steonellis. I'm a research fellow at the PhilLab, at the European Space Agency at the PhilLab, and I will talk mainly about the data introduction and use. Okay, so getting started. I will talk about getting started. There is a notebook example and the Map Your City dataset exploration. The GitHub website is shown in this slide. The username is AI4EO, so Artificial Intelligence for Earth Observation. And the repository is Map Your City. So we have created a started notebook for the AI4EO Map Your City challenge. And yeah, the GitHub repository is shown on this slide. We will take a closer look at the dataset structure, at how to load the data, how to visualize the data, and also the data exploration, the submission format, and the evaluation metric. Okay, so dataset exploration notebook.
the dataset structure. We have a trained dataset and also a test dataset. For the trained dataset, we have the label and also the street view image, the orthophoto and the Sentinel-2 image. For the test dataset, we have the street view image for the 2 cities only, the orthophoto and the Sentinel-2 image. So the test dataset has street view images only for 2 cities. For 2 cities, we have no street view images, and for 2 cities, we have street view images. And we also have the Sentinel-2 data. We have all spectral bands for Sentinel-2 data. And we have the labels as well. So for the training dataset, we have a text file with the labels. And there are 7 classes for the construction epoch of the buildings. And we will see example images from the dataset in the next slides. And we will see more details in the next slides. So the main aim is to estimate the construction year of buildings, the building age. And we have 3 multimodal inputs. So we have cross view images, we have street view images, and also top view images. So we have 3 modalities: street view images and orthophotos and also Sentinel-2 data. Regarding the more general problem, the more general problem we want to solve is the energy efficiency of buildings, and the construction epoch can be seen as a proxy of the energy efficiency of buildings. And the aim is to do this on a large scale. That's why we have cities and we have buildings. And the main aim is to predict the construction year of the buildings. And we are given street view images and top view images. So we have 3 modalities. And the main aim is to achieve generalization to new previously unseen cities. So the test dataset contains cities that are not included in the training data. We also show that the satellite images, we also show that the top view images help to improve the performance. And it's not just the street view images, so the top view images matter as well. And we also examine whether only top view images can be used. So in order to scale this in a large scale, in order to do this in a large scale, we examine whether only top view images can be used, so inference without the street view images. And the more general problem is data fusion. So we have different modalities. We have street view images and top view images. And in our proposed, in the baseline model, we concatenate them and we perform data fusion in the latent feature space. And we will discuss this in the next slides in more detail. Okay, so loading data. We continue with the dataset exploration notebook. We load the data and we use Python and we define the paths to the data. And we load the data in this way. We can also see image samples. So we have, for example, for the training dataset. So the first is index 0. It has the label 5 in this case, and it has a country ID. So we have anonymized the country and the city IDs, and every sample has a unique PID as well. And we have a training and a test dataset. And for the test dataset, we don't have labels. This is for the leaderboard. So we have both a public and a private leaderboard. And I will talk about this in the next slide as well. Okay, so we visualize the images. So we have street view images, and we also have the orthophoto and the Sentinel-2 data. For the Sentinel-2 data, we have all spectral bands. And in this slide, we visualize the images. And we can also plot the 2 top view images, one on top of the other. So we see the orthophoto and the Sentinel-2 image. And all of these are in the Jupyter notebook in the GitHub repository. We can also plot the distribution of the samples. So we have different image samples, and we have 7 different classes for the building age. And we also have several different countries and also cities, and we can plot them and see the distribution of the classes over the classes, also over the countries and over the cities. regarding the submission format, so the submission format is a .csv file, and this is also shown in the Jupyter Notebook and the GitHub repository. And yeah, in order to submit the solution for the leaderboard, for the public and private leaderboard, a .csv file has to be created. Okay, so the evaluation metric. So for the evaluation metric, we use the mean producer accuracy, the average of the diagonal elements of the confusion matrix. So we have 7 classes. We have 7 categories for the building aids of the buildings, and then we compute the confusion matrix, and then we take the average of the diagonal elements of the confusion matrix. And yeah, for the test set, we also have we examine if we can use only top view images, so inference without the street view images. And yeah, we use a specific evaluation metric. In this case, the X% in this slide is 50%, so it's yeah, 50% for the all modalities and 50% for the top view modalities. So we have a combination for the test data set where we do inference with all modalities, with all 3 modalities, and inference without the street view images. And yeah, we add these two by using the weight 0.5. Okay, so some recommendation to participants. So I will talk about some recommendations for participants. So the main aim is to estimate the construction year of buildings, and we have a multimodal street view and Earth observation dataset. We have 6 countries and 19 cities, so we have buildings in Europe, and we have 7 classes. We have 7 categories for the construction year of buildings. As a starting architecture for the baseline model, so the baseline model is based on ResNet, on residual networks, on the model ResNet, and we use convolutional layers that capture the local correlations between features. And for the evaluation, we have the mean of the diagonals of the confusion matrix, and the main aim is to achieve good performance for held out cities. So we have previously unseen cities in the test dataset, and we want to achieve good performance. So regarding the baseline models, we perform training and testing with all 3 modalities. We also examine them what happens when we only have street view images. And yeah, regarding the baseline model, we saw, for example, that there is benefit in using the top view images. So the top view images, so the orthophoto and the Sentinel-2 data, in addition to the street view images, improve the performance. And yeah, regarding the challenge, during inference, we also have 2 out of the 3 modalities. So it is possible to use, it is possible to train on 3 modalities and then perform inference without the street view images. And yeah, in our in the baseline model, we have experiments and comparisons between these different training and testing scenarios. Okay, so for the baseline model, we use data fusion and late data fusion. So we have 3 different encoders and 3 different for the 3 different modalities, and then we perform concatenation of the features in the latent space. And yeah, this is just a certain baseline model. And yeah, the output is the construction epoch class, so it's a classification problem. We use the cross entropy loss function, and yeah, we use all the modalities, and we perform late data fusion in this way. So in the baseline model, we have an encoder for the street view images, a ResNet model. We also have an encoder for the orthophotos and also an encoder for the Sentinel-2 data. We perform data augmentation, so data augmentation improves performance and is beneficial. And for the training of our model, we use the cross entropy loss function because it's a classification problem. We use also the optimizer adaptive momentum, the ADAM optimizer. And yeah, regarding the most important modalities, street view are the most important modality. And the next one is the orthophoto, because it provides context and global information. And yeah, we saw that the orthophoto, in addition to the street view images, is important. So we have performed experiments for the baseline model. We have computed like the confusion matrix and evaluation metrics. And in this case, we saw what happens when we use all three modalities. This is for the baseline model. We also compute metrics like accuracy, precision, recall, F1 score. And yeah, in this case, for example, we see an accuracy of 58%. And yeah, we plot the confusion matrix with the 7 classes, and we compute the evaluation metrics. And yeah, in this case, we note that the evaluation is on a data set that does not include cities in the training set. So we see the generalization to new previously unseen cities. In our baseline model, we also compare with single modality street view images only. So it is possible to only use street view images without the top view images. So in this case, we perform training and testing using only street view images. And in this case, we see a performance accuracy of around 55%, so so less than before. And it is interesting to do such comparisons. So we have single modality models, only the street view images, and we also have all modalities models, so models that use all three modalities and all the information. During inference, we also examine what happens if we use inference only on top view images. So in this case, we perform inference without the street view images, and we do this because we want to do this in a large scale. We want to do this in a large scale, and for every city in Europe, for every building, street view images don't scale well. However, top view images scale more favorably, and we see a decrease in performance when we perform inference without using the street view images. So using only the top view modalities, we see a drop in performance, and this is logical in the sense that the street view image, that the facade of the building contains most information about the building age. So we perform such experiments. Okay, so some recommendations for participants. So regarding our model, we have used the cross entropy loss function. So we have framed the problem as a classification task. However, participants can use a regression task, so they can perform a regression task because the age of the building is a real valued number. So participants can perhaps use regression. Participants can also use segmentation to isolate the desired building, so that the training is done with useful information for the model. So segmentation can help. And also participants can use a validation set with held out cities. So the test set is performed on left out cities, and a validation set using left out cities can be beneficial in this setting because yeah, we want to generalize to new unseen cities. So a validation set with held out cities can improve performance. We have also performed tests and we have examined the performance for the model, for the baseline model, when we use inference and test images from cities that are included in the training data. So that's a different setting. And yeah, we have done such comparisons because they are interesting for comparisons and for research purposes. So we see that the performance of the model increases. So the accuracy increases to 68% when we perform testing on cities that are included in the training data. And yeah, this is an interesting comparison because we have test images that are included in the training data. So from cities that are in the training data, and that's an interesting comparison. We have also used more complicated architectures. So in the previous slides, we have used convolutional neural networks, so ResNet, the ResNet model. We know, however, that transformer architectures are more beneficial, and we have also investigated for research purposes and also for interesting comparisons using a transformer model rather than a ResNet model. And in this case, we have used the segformer model. We have used only street view images, and we have also plotted the performance accuracy per country. So visualizing the error per country and seeing the performance per country is an interesting plot. So we have also done such experiments in our research. Okay, so conclusion. So the main aim is to estimate the construction epoch of buildings from multimodal street view and orthophotos and Sentinel-2 data. The open question is, what is the best overall system pipeline? So it's an open research problem. What is the overall best system? And it's the more general problem is multimodal models. So performing data fusion and combining different modalities. And we have also examined the performance accuracy across the different countries and cities, which is an interesting analysis. And for the baseline model, we have trained and tested with all three modalities. And we have also performed training and testing with only street view images, so without the orthophoto and the Sentinel-2 data. And we have shown that there is benefit in using top view images. And we have also examined testing without the street view images, because in this setting, it is more easy to do this in a large scale for every city and for every building using only the top view images and not the street view images. Yeah, so I think that's the final slide from my side.
Thank you very much, Nikolaus. Thank you very much for this great overview over the data. I'm actually wondering if we will have any questions left. However, let's jump to the Q&A session. Here you have the chance to ask us any remaining open questions that you may have. Again, not only Nikolaus and Nicola are here to answer your questions. Also, Alessandra and Mattia from MindEarth are here, who played a crucial part in the preparation and the curation of the data sets. So maybe they can also answer some questions that go a bit deeper. You can at any time use the Q&A panel of Zoom to ask any questions you might have. You can also post these questions anonymously, so don't be shy. If you would like to ask us any questions after this webinar, maybe something more personal or so, you can also reach out to us at any point, writing an email to hello@AI4EO.eu. And with this being said, we actually have the first two questions. Let's start maybe with the first one from an anonymous attendee. According to Sentinel-2 documentation, multispectral camera is supposed to have 13 bands. However, giving dataset only has 12. Is there any particular reason? Maybe I give the question to the panelists.
I can reply to this one. Basically, this band number 13 actually is at 60 meters, and this is used for atmospheric correction, let's say. And with this band, I mean, you don't sense, let's say, the ground on Earth, so it's basically useless for any task linked to the surface, let's say. So this is why we do not integrate this band.
Okay, thank you very much, Nicola. I hope that answers the question of the anonymous attendee. Let's go to the next one, also anonymous. A question regarding the public-private test set. Can we assume that both splits contain samples from all test cities?
Yeah, I can perhaps answer. So there is a public and private leaderboard. They are unseen cities. So previously unseen new cities.
Okay. I hope that answers this question. And again, if you feel that any parts of your question have not been answered correctly or in full expense, then please reach out to us again, either via the chat, via the Q&A session, or after the webinar. A more administrational question: is it possible to change team names after registration? This is actually a question we would have to clarify with our site administrator. I can check at a later date and come back to you regarding the name change. If you want to have a name change, maybe reach out to us via email so we can get this done directly with you. And then a question from Raphael: will the labels for the test set be made available after the competition ends? I think it would be important for future researchers.
I can maybe try to answer, even though I don't have the answer actually. I mean, we haven't decided if at the end we'll make this. I mean, the test label available to the community or not, or we'll keep it for further benchmark. And so, but thanks for your remark. We'll consider it and we'll think about that. Thanks a lot.
Okay. Then we have another question that's similar to what we just had. Is the distribution of country cities the same in the public and private parts of the test data? Maybe Nikolaos, if you would like to.
Yeah. Okay, so so for the leaderboard, we have a public and a private leaderboard, and yeah, we use two cities for we use so we use 4 cities for the training for the testing. We use 4 cities that are not included in the training data. So for the public and private leaderboard, we use 4 cities that are not included in the training data, and and yeah, so I think the distribution. So the question is the distribution of country cities the same in the public and private parts of the test data?
If I can complete, I think this is these are the same countries and cities in between the public and the private. This is a random sampling and distribution. So these two has been equally shared in between the private and the public, but they belong to the same countries and cities. And it's a pure random split in between the private and the public leaderboard.
Okay, that should answer this question again. Or Mattia, Alessandra, if you want to chime in at any point, please feel free.
Yeah, I can just add that as you also touched previously, we spend a lot of time in curating the data, so you can expect basically no major differences between the two, also qualitatively speaking. So again, there should be no bias due to this.
Okay, thank you very much. One more question just came in. In the challenge page, it is mentioned that cloud computing could be provided. If yes, how could we do it?
I think it's quite simple. You just have to reach out to this email, which is hello@ai4eo.eu, and then we'll grant you access to this cloud computing. Basically, as a side project of the AI4EO challenge platform, we have also the EOTDL platform, which is here to help on the training data set, let's say, and here you will have access to cloud computing and also the data set directly there. So please reach out to us, and then we'll help you to have access to this GPU machine.
Okay. Another question just came in. Is it allowed to be a member of 2 teams at the same time? And here, I guess I can also take the answer, Nicola. You can always chime in, but actually, no. To keep things fair and to keep things a bit more, let's say, challenging between teams, we would like to have closed teams that work on their solutions themselves. So it is not allowed to be a member on 2 teams at the same time. And please also be aware that it is not within the rules of participation to, for example, create, let's say, 2 teams to test the own submission file 2 times, because obviously we have 3 winning teams in the end, and we would like to have 3 different winning teams and 3 different solutions. So that is unfortunately not allowed. So looking at the Q&A tab. One more question. An anonymous attendee asks, I have posted on Discord for GPU access as shown on the platform instructions. Do I have to send an email now? I guess if you have reached out on Discord, yes. Yeah, we can back to you.
No, no needed.
Yeah, we can reach out to you directly on Discord. Obviously, always feel free to reach out on Discord as well. That is our most direct way of interacting with you, apart from the webmail. And of course, you can always post on the forum of the AI4EO challenge website. Another question. Would you say it's feasible to have a single trained model winning the competition, or will it be weaker than a model assemble with some parts trained with and without Street View? That's a very good question. Who wants to take it? Maybe
Nicolaus, would you like to take it? It's a tricky one.
I don't see the question in the Q&A. Yeah, could you perhaps repeat the question? I think it has to do with Street View and...
Let's just put it here for a second.
Images.
Would you say it's feasible to have a single trained model winning the competition, or will it be weaker than a model assemble with some parts trained with and without Street View? You can also see the question on the screen, hopefully.
Yeah, it's an interesting question. So I think, yeah, I think the model ensemble could help. Yeah, so the model ensemble, yeah, could help because, yeah, training separate models and performing then an ensemble, you can achieve in this way better performance. Yeah, so I think, yeah, my best guess would be that, yeah, perhaps a model ensemble could win the competition rather than a single model. Yeah, however, we have to see, and we have to see what happens.
I hope that answers this question. Let's maybe wait a few more seconds for other questions to come in. It's actually quite interesting so far. We don't have any frequently asked questions, so questions that have reached us several times. So we hope, obviously, that the rules page is relatively clear on that front. We have another question. Will a copy of this recording be made available publicly? Yes, of course. We will upload the recording of this video to our AI4EO YouTube channel. There you can also find the recordings of previous webinars, for example, of the Orbital AI Challenge. There you can also find useful resources, useful information on different topics regarding the AI4EO challenges. Also, for example, a little pitch seminar, actually. So definitely swing by, and we will publicly announce when the video is online on our channel. Let's wait a bit more if any other questions come in, and then obviously, as mentioned beforehand, if you have any other questions afterwards, please to reach out either on Discord or hello@ai4eo.eu for any other questions. But I think this has concluded it. 10 questions, 10 answers. So we hope that this helps you in your way forward and in developing your very own solutions. We would like to thank everybody for joining today's webinar. Again, a big thank you to Nicola and Nikolaus for joining today from ESA, especially you, Nikolaus, for your great overview of the data and the Jupyter Notebook. A great thank you to Alessandra and Mattia from Mind Earth again for the amazing data set that they have curated. If there are any other questions, we will obviously also forward it to Nikolaus and to the team of Mind Earth to give you the best possible answers. So without further ado, we will update the recording as mentioned at a later date on YouTube. Thank you very much again for joining. Nicola, would you like to have the last few words?
No, thanks all for joining. I hope that you enjoyed this webinar as much as myself. Actually, it was a good moment with you guys and with Nicolas as well, presenting the main content of this challenge. So yeah, keep in touch. If you have, again, any comments, feel free to contact us, and we'll be happy to provide you any replies to that. Have a good day, good evening, or good night.
Thank you very much. Have a good day. Bye-bye.